Hi, this is Nelly Purkastri. I'm a data architect and analyst. I want to share with you my project at the Scotsman Guide to update their ranking system. So currently they have 12 different ranking. Each of them, they have their own reports. So they have to maintain 12 reports. They consolidated to 9, but still 9 is a lot to handle. I decided to use Tableau, create a report in a single page with all the 9 tiles as the filter. As you can see, user click on a tile, the ranking page opens. They gave me the raw data in an Excel file. I downloaded it and created a table in Databricks. I gave it an ID and I created a ranking system with SQL. Next thing I did, I connected to that table through Tableau and started building. The first thing I did, I created a parameter called selection that has different choices. The selection with the action that I created is going to filter the table. This is my ranking calculated field. For each selection, it's going to pull up the appropriate field. I brought ID and state dimension, select my first measure into column, and brought the dummy 0 in there. The parameter selection, I put it in there. I'll each have a different value. And I brought the display value into dummy labels and changed the measure type to bar, size it to minimal, the same for my measure, change color to white to be invisible. We only need titles. Then dual access it and sync them. Dummy title to display. Tick marks to none and remove the vertical lines and remove the measure names. And then custom range 0 to 1. I did the same thing for each measure. And I named them the way that I can find them: 2A, 2B, 1A, 1B, because one is volume and the other one is count. Since the rank needs to be on the left and it's a numerical value, I had to do this for my dimensions as well. So I follow the same thing for dimensions. The problem with this was the column size is not adjustable. So they all have to be the same size and it's a waste of space. So I came up with a different method. I brought everything into the table, all the display values. Change the chart to polygon, and as you can see, some of the names are not what I want to show, so I hide it. And I created a new table just for the header. I leave like one line space, so in this case, all gonna be unique and look better, as you can see. So this is my second approach. This way, the column name is in a separate sheet, but the size is adjustable. Now that I finished building the dashboard, I want to talk about the actions. These 9 tiles represent specific action that set parameters values. I'm bringing the choice parameter to the front so you can see how clicking each tile changed the value. This selection dynamically updates the table below, the sorting logic, and the dashboard title. I'd like to quickly show you how I built these tiles. Looking at the layout pane on the left, you can see I utilized 3 by 3 containers to organize the tiles and maintain a clean structure. I'm actually maintaining 2 sets of tables and headers. One set handles the first 8 individual ranking, while the global ranking is a unique combination of all of them. The global ranking behavior is different. This is how I design it. While both tables sheets have 10 columns, clicking a column header in the global ranking is designed to trigger a sort for the entire dashboard. In the header containers, I placed the first 3 static fields together and then added each sortable option as a separate sheet. Combined, they look like a standard column header, but they're fully actionable. I placed a global value parameter on the dashboard and hit it. The actual value is in the measure mark. But since the dashboard uses polygon mark, it remains invisible, still providing the necessary sorting data. If you look at the layout pane on the left, you'll see the complex hierarchy of nested containers used to achieve this alignment. As you can see, clicking on each tile or each header will change the title of the dashboard. It gives the user what they're selecting and what they're seeing. I use a calculated field for the title, so it changes based on the parameter. I also use 2 calculated fields for the columns in a separate sheet to manage the layout. Finally, I want to show you the borders, which only exist in the row headers. To achieve the specific background colors that I wanted it, I used the container backgrounds rather than just sheet backgrounds. The final step is making this report accessible to the public, which requires a strategic workaround since the source data is secured behind the Databricks cloud. To publish on Tableau Public, I first need to bridge the data, so I ensure my Databricks serverless and all-purpose compute are active. I then utilize a Google Sheet integration, using the Databricks extension to connect to our specific catalog and schema. Using the SQL editor, I run a query to pull the clean rank data directly into the Google Sheet. Back in Tableau, I connect to the Google Sheet as the new source and perform a replace data source at the worksheet level. Because column name can shift during this transition, often adding _1, some calculated fields may temporarily break. I manually audit these fields, cleaning up the naming conventions and using replace references to ensure the architectural integrity of the report remains intact. Once the calculated fields are repaired, I publish the dashboard to Tableau Public under a professional file name. For security, I strictly disable allow access setting to prevent users from downloading the underlying workbook or raw data. The result is a secure high-performance dashboard that is now ready to be embedded directly into the Scotsman Guide website. By leveraging Databricks, Tableau, and Google, I have created a reporting tool that goes far beyond the standard capability of these platforms. As a data architect specializing in AI and BI, I didn't just build a set of tables. I engineered a scalable data pipeline and a custom UI framework. This system provides a seamless, professional experience for the end user while maintaining the highest standard of data security and backend efficiency. This is how we transform complex raw data into actionable, public-facing intelligence.